So hello everyone, we are back again with our latest video on SQL tutorial Ebikacho by Ebikacho groups. So basically the agenda of this particular video is we are going to discuss SQL Server system data types. So basically we are going to discuss the data types in this video and what are the data types we are using in SQL Server and all. So this particular session will be important in all aspects, means in other languages also if you go to code, then you must know the data type and how they are working, and in almost every language and the data types are almost same. Okay, so let's move on and check what we are going to discuss in this particular video. So what are first SQL Server system data types? So in SQL Server, system data types define that what type of data that particular column can or variable can store, or the parameter can store. Okay, that is clear. Means the data type will define you what type of data we can store in a particular column, variable, or a parameter. So basically the types of system data types are like that: exact numeric, approximate numerics, date and time, character string, Unicode character string, binary strings, other data types, CLR data types, and spatial data types. So other data types are some means some of the data types that are different and not in most uses. So that also we will discuss. Now move on. So basically what we have done, we have distributed this particular SQL Server data type thing into three videos. Okay, so this topic we have distributed in three parts, and in the first video we are going to discuss exact numeric, approximate numerics, and date and time. So in this video we are going to discuss the video one, and then in video two we are going to discuss the character strings, Unicode character strings, and then the binary strings. Okay, and in video 3 we are going to discuss the other data types, CLR data types, and spatial data types, because all will take in a one video, it will take a huge time and huge space, and it will make the video also little boring. So we have means distributed in three parts, and will provide you a good clarity over each of the parts. Okay, now move on. So basically these are the data types we are going to discuss in this video: exact numeric, approximate numerics, and date and time. So in exact numeric we have bit, tiny int, small int, big int, numeric, decimal, small money, and money. And in approximate numeric we have float and real. And in date and time we have date time, small date time, date time offset, and date time 2. Okay, now let's move on to our first particular data type. So first of all, we have the bit data type. So what it is doing, the bit data type in SQL Server is designed to store Boolean like values, which can be one of the three possible states like 0, 1, or null. Okay, so bit is basically a very small unit, and it will store like Boolean data type, means it will verify you that either the particular thing is true or false and all. And it will means store only small values like 0 and 1 or null. These three values can be stored in a bit data type. So it is commonly used to represent true and false, as I have told, or yes and no scenario. So basically, when you are going to an organization, so when you are modeling your data, so one of the data you will keep like is active column. So that means if any record will be deleted, means if any purpose you get where you need to do soft deletes. So in that particular cases, you can put a column like is active, or any flag column you will provide like is deleted, is to be deleted. So these kind of columns we can take bit type data type, so that they will consume less space, and they will be referenced while creating a view or a store proc on top of that particular table. So bit is also means this particular data type we will use most frequently in our projects while doing the data modeling. And in optimization point of view also, one bit is a very small unit, so we can use this. So go on SQL Server Management Studio and we will check how it will work. So basically I have also created one example. So like here what we are doing, create table example I have provided. So let's go to SSMS and use this particular query. Okay, copied this. Now go. So first of all, let's create a new database for this particular topic. And already we have mentioned the how to create the databases in our uh, previous videos, so you can check that also. We also have a full course on SQL Server. So now this database name we will keep like system system data type practice. Okay, owner will be default and all other settings will be default. Now press OK. Now expand this database. Then here we have our system data type practice database. Okay, now expand this. Currently this is completely empty because we have just created this. Now right click on the system data type database and go to new query type. Okay, now paste this query what we have. So what we are doing here, we have created a table, example table, where we have two columns, id and age active. So age active is a bit data type and id is a int data type, and id is the primary key. Now first execute this create statement, and then what we have, then we are inserting some values in this example table. So insert into example table, then column name mention id and age active, and values what we are going to give 1120 and 3 comma null. So insert some values plus control R, execute, then 3 records affected. This is fine. Now check what kind of data it is providing to us. Okay, so it has taken very less space in our database because we have taken is active column as bit. So one bit is a very small space, and you can see it is storing 10 and null. And let's check what if we are trying to put any other value in a bit data type. So for that we will check via a variable. So for variable, first of all, what you need to do, first comment all these codes. When you press Ctrl A, it will select all the things what you have in a particular page. Now first declare one variable, declare at the rate bit bit test, we can mention bit test, and the data type we will keep like bit. Okay, now set the C intelligence is providing me the option to select that particular variable only. So and in my previous video I have also mentioned how to open the intelligence in SSMS and how to use it. So we will mention a different value like 4 if we will take, and then select this variable, select at the red bit, copy this and paste this. So now execute this. So when you have given a variable, then you need to execute from the declare part, means all you need to select declare part, set part, and then the select part. Okay, now execute this. Okay, so what we are getting, one we are getting. So if you provide any other means integer column integer value to a bit data type, then it will convert it to one by default. Okay, so that is clear for bit. Now move on to the next data type. Press Ctrl R. Then after bit, what we have? After bit, we have the tiny int data type. So what it is doing? The tiny int data type in SQL Server is specially designed to store very small integer. So whenever we need to store some small integer values and all, like pin code or something, then we can use this tiny int data type. Okay, because it will consume less space and will be more productive. So tiny int is a 1 byte integer. Okay, so in previous page we have seen like 8 bits will make 1 byte. So you can imagine how much bit is smaller than that of tiny int. Okay, so tiny int is a 1 byte integer data type used for storing numerical value ranging from 0 to 255. Okay, and it is unsigned, meaning negative numbers are not allowed. So this is a point to mark, like negative values we will not provide in the tiny int data type. Okay, now let's move on to SSMS and check this particular example that we have pasted for tiny int. Okay, now go open a new query window. Okay, by using these examples, our data set will also be created, and these data sets we will use in our further videos also. Okay, so that is clear to everyone. Now first here we are doing, here we have created a table like tiny int example, and here we have two columns id and age is our tiny int. So tiny int we can use for ages also, because age will always be, age of a person will always be under 0 to 255 max to max, not that much, means people can go 100 maximum, but we can keep this tenant because it is handy to capture and it will load, means less data it will cover in the database. Okay, and the query will be optimized. So first create the table, then we are inserting some values here. Insert into id and age values, these are the values. Now execute this, and now check how the data is stored. Now select star from tenant example. So see, all the data are stored properly, 1 2 3 255. Now we need to check how it will react if we provide a greater value than 255 or a negative value. Okay, so let's comment this particular code and go declare a variable. So we have already seen how to declare a variable and how to set value for that. So we will use that only for this tiniint also. Declare at the rate tiniint tiniint. So for declaring a local variable, we are using at the rate, and for global variable, we need to means paste double at the rate for a global variable. So global variable have the full scope, means it will work here also, and in this particular tab also, and this particular session also. Means it is told in SQL language, SQL term it is called session, and basically you can refer by page also. That is not a thing to worry about. So if we use here, if we have declared this particular bitwise here and we will use here, then it will not work. Okay, and also means the variable will only work after just after the declaration part, and below also in that particular session you can use a variable that you have declared. Okay, so now here in this session we have declared the tiniint and give the data type to tiniint. Okay, now set the value greater than, set at the rate tiniint equals to greater than 255, 256 we will take. Now what it will give us, now select the variable, select at the rate tiniint variable. So see how much efficient the code is being uh, by using the intelligence. Okay, now execute all of this. So see what error we are getting, arithmetic overflow error for data type tiniint value 256, means the data is getting overflowed, means that is not the container size. So the container size is until 255 itself. Okay, tiniint can hold up to 255. So when we mention 255, then execute, then we are getting the value 255. Okay, and now when we use a negative value, let's try with a negative value minus 255 if we will take, then again we are getting the same error, arithmetic overflow error for data type tiniint value minus 255. Okay, that is clear, means it will contain only positive value and the values between 0 to 255. So that is clear for tiniint. Okay, now let's move on to the next data type. So what we have after tiniint? After tiniint, we have the small int data type. Okay, so the small int data type in SQL Server is designed for storing small integer values. Okay, for storing small integer value. It strikes a balance between storage efficiency and a reasonable range of values. So it will also provide you a reasonable range. Means like tiniint we have only 255. The range is 0 to 255, and also negative values are not allowed. Okay, so but we can't use that for all of the our integer columns. So small int is a better option to use in place of that, because it is a storage efficient also and reasonable range also it will provide. So what is the storage size in small int? So it occupies around 2 bytes. Okay, means 16 bit it will occupy, and ranges from 32,768 negative to 32,767, and it's a signed integer. Means unsigned integer means it will contain only positive value, and signed integer means it will contain both negative and positive value. Okay, now copy this particular example and we will check in SSMS the working of a small int also. Okay, now open a new query window, press Ctrl R, new query. Now paste what here we are doing. So here also we are creating a table, small int example, id and age will be our columns, and here age is the small int. Okay, now create the table first. Now we have a insert query for inserting some records, insert into small int example id age, and these are the values. Okay, now execute this. Now select the record, how it is providing the record, select. Okay, so see negative value is also getting considered, and greater values are also getting considered. Now we will test if what will happen if we provide a range greater than the range that we have that is provided for small int, which is between 32,768 to 32,767. Okay, so let's check once. Now again declare a variable, control Z, the code is gone. 1 second. Declare at the rate small int as small int small int data type. Now set at the rate small int to let's take 32,768 we will consider. Now when we are selecting the value, what it is providing, select at the rate small int, copy paste. Now execute this, what we are getting. So see, arithmetic overflow error for data type small int occurs because the limit of the data type has been crossed. 768 we have provided, and let's try it for negative value. So negative value, it is allowed from minus 3 32,768, so it will provide you some value. The value means that value only. Okay, so that value is coming. Now if we increase or decrease, means decrease some value like 66 we will take, then what it is providing, null. Okay, means arithmetic overflow error for data type small int, value itna. Okay, so got it, small int is also clear to everyone. Now move on to the next data type. So after small int, what we have the int data type. So basically what int data type is going to do, the int data type in SQL Server is used to store integer values. It is a whole number type, meaning it cannot store fractions or decimal. Means fraction or decimal it will not hold, integer data type, and only positive or negative integer will be applicable for this int data type. Okay, and the storage size for integer data type is 4 bytes. Okay, 4 bytes means 8 into 4, 32 bits. Okay, which allows it to represent values ranging from see, the values are in around billion. So around 2 billion negative and 2 billion positive values are allowed for integer. So integer is the data type that you are going to use most frequently because it is providing you a big range also, and it is capturing also the negative and positive values. So that is fine. Okay, now go and check the example also how it is working. Okay, copy this. Now move on to SSMS. Open a new query window and then paste. So what here we are doing, here also the same thing, create table employees, we are creating a employee table, and then columns will be our employee, age and salary. Okay, now execute first create statement and then insert some values. What values we have taken like insert into employees, column names and then values. Now execute this. So values are inserted. Now let's do a select star from employees. What kind of values we are getting? Select star from employees table. Okay, now select this and execute select star. So see, we are getting the proper value like 1 to 3 age and salary. So here what we have taken, age and salary are all the three columns are our integer column. Okay, now check the range of int also one time by the variable and check what it is giving the error when we are exceeding the range. So now first declare one variable at the rate int integer. Integer variable we have, the data type will be int, and then set the value to set at the rate integer to greater than the maximum value. Now let's go to the pt and check the maximum value what we have. Copy this. Okay, now paste it here and increase one value, 647 648 we will take, and remove this comma signs. Okay, remove these commas so that it will not consider it as a string. Okay, so now integer, now select this, select at the rate integer. Now execute what we are getting. So see, arithmetic overflow error, same error it is also providing. Now when we are taking the ranged value, so it is providing us the value. Okay, and also negative we will check, negative also it is providing. So see, okay, so it is working as expected. Now move on to the next data type. Okay, so after this what we have, after integer we have the integer, then big int. Okay, so what big int is doing, go to big int. So the big int data type in SQL Server is designed to store very large integer values. Okay, if your work is not happened by using that integer data type, if you want more amount of data to be stored, then you need to take big int instead of that integer column. Okay, so it uses 8 bytes of storage, whereas how much int is using 4 bytes and big int is using 8 bytes. So it uses 8 bytes of storage and offers a much wider range compared to int. This makes it ideal for cases where your data might exceed the range of standard integer type. Okay, so whenever your data increases the range of integer data type, then you can use big int. Okay, and you can see a range of big int is very high. This is the range that is provided and it is very high. Okay, so now let's move on to SSMS and check this example also. We can check this also one time. Now go open a new query window. Now here what we are going to do. So here also same, create table large numbers. ID we have given big int and population we have given big int. So population can be calculated in big int because means the population ranges are much higher in every country. Now create the table first and then insert. There are some records which are we are inserting. So these records are exceeding the integer range. You can see here 1 10 100. So around 50 billion record we have, and the range of integer is around 2 billion plus. Okay, but less than 3 billion. Now insert these values and we will check how it is working. Now put a select star on large numbers. Select star from large numbers. Sorry, large numbers. So see how intelligence is making our life so easy by providing the table names and also see it has given the result ID and population. So for this we will not use the range exceeding checkup because the range of big int is very high. Okay, now move on to the next data type what we have. So after big int we have numeric. So this is also very important data type you need to consider. Now what numeric is doing? So the numeric data type in SQL Server is used to store exact numeric values. Okay, exact numeric values where precision and scale are specified. So precision here is the number of total digits that you are using, number of digits you are using, and scale is are the digits after the decimal sign. Okay, after decimal how many digits you are providing, that is the scale. So it is functionally equivalent to the data type. Functionally equivalent to the like here it has missed. It is functionally equivalent to the that data type. One second. Functionally decimal data type. Okay. So it is functionally equivalent to the decimal data type, and both are often used in interchangeably. Okay, used interchangeably means either you can use the decimal data type or numeric data type. It will not make any effect. And allowed range is between 1 to 38. The precision means total you can take 38 digits, and the amount of storage depends on the precision, means how much digit you are taking. So if you take 1 to 9 digits, then 5 byte will be the storage. If you take 10 to 19 digits, then 9 bytes will be the storage. If you take 20 to 28 digits, then 13 bytes will be the storage. And if you take 29 to 38 digits, which is the last, means it allowable range is the 38 digits maximum, it takes 17 bytes. Okay, so see how huge amount of memory it is taking. So when you are using this numeric and decimal data types, so be more clear about how much digit you want to put it there, because the storages are going to grow. So optimization point of view, it will be very means important to check about that. Now check this example also we will test. Open a new query window, then paste this. Then here what we are doing, we are creating a product table. We have provided product ID as integer, then price as numeric, and here the precision is 10 and the scale is 2. Means till two decimal places it will go, the price. And the quantity we have taken numeric with precision as 6 and 0 as the decimal place. Means after decimal no value will be there. Now create this particular table. and then insert the record. So insert record, we have the insert into table, product table, column names, values. So see, this kind of value also we have provided as per our table, uh, till 10 precision, and then the decimal is 2 in price. Okay, insert these records, and then we will check the data. Now put a select star into select star from product, select star from products, see products. Okay, now execute this. So as you can see, same results we get. Okay, now let's do some practical on numeric data type, like how we are getting the, if we have mentioned different scale and different precision, then what kind of data it is returning to us. Now declare a variable of numeric type, declare at the rate numeric test, and this will be numeric, and we will take the precision to be 10, and then after decimal places we will take like 4 we will take. Okay, and now then set the value to something like 1 2 3 4 5 6 7 8, and after decimal we will provide something like 1 2 3 4. So see, we have exceeded our precision. Set at the rate numeric, sorry, here little bit we need to put the numeric also. Set numeric equals to this. So we have taken 8 and 4, 12 digit total we have taken. Now select this, select at the rate numeric test. Now execute this query, what result we are getting. So see, it is throwing the error, arithmetic overflow error. Okay, now change the digits, move some places like 4 8, so do it 10, 6 and 4. Now it will provide us a proper result. Now execute this. So see, it is providing the exact records. And what if we have provided means more values after the in the scale part? So let's do like 4 5 6 7 8 9. Okay, and now execute this. So again it is, now see, if you provide means some more values after the decimal part, like in the scale section, then it is rounding it to 4 digits. How much scale you have provided, that much is it rounding that. Okay, that is clear to everyone. So now let's move on to the next data type. So after numeric, what we have, numeric is done, then we have decimal. Okay, now decimal, what it is doing. So the decimal data type in SQL Server is used to store fixed precision and scale numbers. It is functionally identical to the numeric data type, and both terms are often used interchangeably. So as I have mentioned while discussing the numeric only, both decimal and numeric are almost same thing. Means are almost same thing, identical. Only the name changes. And allowed range in decimal is also 1 to 38, and the amount of storage depends on the precision. Means as per as we are growing the precision, the number of storage increases, amount of storage is getting increased. Now also we will take the example for this and check. So copy this and paste to SSMS, paste. Now here what we are doing, here the same thing, product table we are populating, but the data type will not create. So see, this is also one thing to show you. If you create the table with the same name in a single database, then it will throw an error. There is an already an object named product in the database. Okay, so that is the thing. And even other product other objects also you will create with the same name, then it will not take same error, it will throw. Now change it to products 2 underscore 2, and here also underscore 2, control R. So now execute this, this will take it. Now command completed successfully, and then insert values into product 2. Okay, this is also done, and now execute. So see, we here we have taken the data types product ID will be int, price will be decimal, quantity will be decimal. And now execute this and check. Select star from products to. Okay, so this is also providing the output as expected. So I think this is also clear to us. Means decimal and numeric both are same thing, but only the names are changed. Okay, now move on to the next data type. So what we have after decimal? After decimal, we have small money. So if you have financial kind of data and all, so then this particular data type will be very useful for you, and you are going to use it regularly. Small money and money, that we will discuss after this. Okay, so what is small money is doing? So the small money data type in SQL Server is used to store monetary values where smaller range and high precision. Okay, smaller range is required and high precision is there. It requires less storage than the data type, making it suitable than the money data type. Okay, that is missed here. So it required less storage than the money data type, making it suitable for scenarios where memory optimization is an important and the monetary value falls within its. Okay, okay, 1 second. That is clear now. For scenarios where memory optimization is important and the monetary value falls within its range, it takes 4 bytes of storage. Okay, and range will be minimum this much and maximum this much. Okay, that is clear. Means monetary is used for means keeping like uh, you can say monetary data, financial data, because there we need more accuracy, and we can't means put them like that. Okay, so now check the example and we will see how it is working. Now go to this, and the range of small money will be minimum this to this, means around 2,14,000 to 2,14,000. Now go to SSMS and check the working of money data type. Now here what we are doing, here we have also created a table, product pricing, and then product ID, unit price, and unit price will be our small money data type. Now create this table and then insert some values. So insert into pricing and product ID and unit price. So see, now we will execute this, insert the value, then we will check first and then we will discuss. Now select star from product pricing. Okay, now execute this. So values are coming as expected, minus minus. Now let's check what will happen if we provide a higher range value, then how it is behaving, the small int, a small money data type. Okay, so now first declare ARE CL, sorry, declare at the rate small money, and data type will be small money. Okay, now set the value to set at the rate small money to. Now go to PPT and copy the highest value that it has, like 2014 and 2,14,748 dot this much. Go to SSMS and then paste equals to this. Remove the comma sign. It will consider it as a string if we put the comma sign, and then now select at the rate small money. Now see, if we increase the length by one digit, not this one, we need to increase the precision here. It now before the decimal, if you increase, then that will work. I think this will also work. We will check both of them. Okay, now 8. See what is it is providing. See, so it is providing that arithmetic overflow error occurred, converting numeric to data type small int. Okay, overflow happened, means the same error. Okay, and now test it with the same data, same value what we are getting. So now it is executing it fine. Okay, and now when we increase some precision also, then what it will do, it is rounding it or not, that we will check. So see, it is also not rounding it. Okay, so maximum digit after decimal, what you can give. 1 second. That is the point to catch here. 1, 2, 3, 4, 5. Okay, now when we give this, so now it is rounding this. Okay, that is clear now. So total that much total value will be that much, 2,14,000 and 748. So if you exceed this particular value, then it will fail. Okay, so small money will be clear, I think, to everyone. This is also working similarly like usual. Now move on to the next data type what we have. So after small money, we have money data type. Okay, so money data type is also important if you have a financial data. So what it is providing, it is also providing a greater value, and working will be same like that of small money, but more values we will take here. Okay, so the money data type in SQL Server is used to store monetary values with fixed precision, 4 decimal places, and uses 8 bytes of storage. Okay, total 8 byte of storage it is taking, and it is suitable for financial operation where accuracy is important, but for greater precision. Okay, precision will be greater, means number of digits we can mention great more, but after decimal place it will take only 4 character. If you give more character than 4, then it will round it up to 4 character. Okay, and for small int case also that is the thing. If we will increase the number of digits after decimal place, then it will round it up to 4 places. Okay, four, you can say scales, four digits after the decimal place, but precision in case of money is greater. Now what is this? Money can store value from this much, you can see very high records are there. So from this particular value to this particular value, you can store the value in money, and it is also providing 4 decimal places maximum. Now we'll check for that money. We will also check. Take this particular example, and we will try in SSMS. It's working. Okay. Now open a new query window. Paste this. Now create table product prices. I think here also we have used product pricing here, and here is the product prices. So table name is different, and here we have provided the product ID column, product name, and price, and here the price will be our money data type. Now execute this, create the table, then insert the value to see what values we have. Okay, that is fine. Now select and check what kind of record it is providing. Select a star from product prices, copy and paste this. Now execute this. Okay, so the results are coming as expected. Now let's check what happened with money data type if we are providing more number of digits after the decimal place. So first take an example, declare one variable, declare declare money test, money test, then put the data type to be money. Okay, and then set money to your bank account. What a joke. Okay, now set at the rate money equals to let's check 1 2 3 4 5 6 7 8, and then we will provide the decimal also to 1 2 3 4 5 6 7. Okay, now execute this. Select at the rate money test. Now execute this. What we are getting? So we have, see, we have provided 7 digits after the decimal place. Now execute. So see, it has rounded it up to 4 digit. So maximum it will show you 4 digit only. So when you are checking that, means when you are working with a financial data that has a little more decimal places, then at that time you can't use money and small money. Okay, in that cases, what you need to check? You need to either check the decimal or numeric you can use, but money and small money will round up your digits, so you will not get that much precise perfect data. Okay, now move on to the next. data type what we have. So I think this much is clear to everyone. Now move on to other one. After money, we have float. Money, then float. Okay, float data type. So float is also the common data type that you are going to use every day, and in all of your table, almost a single column will be kind of float, where you have some numerical values and all. So float is also a common data type. So what float is doing? The float data type in SQL Server is used to store approximate numeric values with floating decimal points. So it is also means capturing decimal values, and it is suitable for representing very large and very small number with a high degree of precision, but it may introduce rounding errors. See, it may introduce rounding error due to its approximate nature. So in scaling part, if you provide a certain digit and you are providing some means larger amount of values after the decimal places, then it will also round it up to the scale that you have provided during declaring this particular data type. Okay, so be clear on that part, means what, how much length of your data can be possible and how much digits you need to consider after the decimal place. Otherwise, you will end up getting a rounded record, which will cause some error in your calculation. Okay. In all the cases, in even numeric case also, that you need to be careful. In decimal also you need to be careful. And money and small int, you already know that they will go up to 4 digit only. After that, they will round it up. Okay, so that is the case. And then float is commonly used in scientific or engineering calculations. So basically for calculation we are using this float because it can provide small to small and large to large values, both it can provide. And here also the storage size will depend upon, if float will be 1 to 24 precision, then you can use 4, then it will use 4 bytes of space. And if float is between 25 to 53 precision, then it will use around 8 bytes. So default is 53, means default precision is 53 that is providing. Now let's take this example. Here we have not created any table, we have directly taken the example from the variable. Okay, now move on to SSMS and check this. Now here what we have taken, we have declared a value of float data type and then set the data type value to this particular. So in float it is not mandatory to provide the precision and scaling. That is one thing you can consider. Okay, now select at the rate value. What is it is providing? Execute this. So we are getting the same record. Okay, now this is clear, I think. Now move on to the next data type. Float is clear. Float is easy, only common thing. Now move on to the next data type what we have. So regarding decimals, what we have, how many data types we have? We have like you can consider numeric, then we have the decimal, then we have the float, then we have the money, then we have the small money. So this much for decimal type data types. Okay, now move on to the next data type. So here we have real data type. Okay, real data type, what it is doing? The real data type in SQL Server is an approximate numeric type used to store floating point numbers. So it will also means used to store the floating point number. So decimal, it will also capture decimal values, and it is essentially a shorthand for the float data type with a precision of 24 bits. So it is a shorthand for float data type with a precision of 24 bit. That is clear. So the real data type takes up 4 bytes of storage. So the storage is fixed here, 4 bytes of storage, and range is between, there is the exponential value that is mentioned here. Okay, so it will also work like that of float. Now pick this example and we will check in SSMS how it is providing the data. Copy this. Now go to SSMS, open a new query window. Then here what we are doing, we are creating a sensor data table, and then here we have provided the sensor ID, then temperature, then humidity. Temperature and humidity will be our real data types, and sensor ID is integer. Now execute this. What result we are getting? So this is completed. Now insert some values. So these are the inserts that we are going to insert into the table sensor data. Now execute. Now select the result and check how our data is coming. So select star from sensor data. Okay, now execute this. Okay, so we are getting the results as expected as we have inserted the value. Okay, now real is also clear to everyone. This is also simple, same as that of float only, but with little bit less amount of data it will capture comparing to float. Now move on to the next data type what we have. So after real, we have date time data type. Okay, now the date time data types came. So what we have discussed until till now, two of them we have discussed. This is the third part, which is date time. Now date time, what it is doing? So the date time data type in SQL Server is used to store both date and time values in a single column. So it will store both the date and time for in a single column. Okay, it is widely used for tracking events or timestamps in applications. So basically in applications, what is the thing we get, like who has logged into the application and when they have logged in, so exact time we want. Okay, so basically date time will provide you both the date, on which date they have done, and at what time they have done. So for capturing the events and timestamps in application purposes, we can use this date time data type. And date time occupies 8 bytes of storage, so huge storage it is capturing. Okay, and date time store value in the format of YYY, mm, DD, HH, where HH is the hour, mm minutes, SS second, dot mmm. Dot mmm is the millisecond. Okay, so where dot mmm is the millisecond, represents millisecond, and it will provide you up to 3 milliseconds only. Now let's take this particular table and we will check from this example also. We will check, and then using get date we will check all the date functions, because get date will provide us means all the examples in one go. Now go to a new query window, then paste this. Here what we are doing, here we are creating a table employee schedule, and then we have the columns employee ID, schedule start, schedule end, and schedule start and end will be our date time. Okay, so employee when he has logged in logged out, that time is also captured from this date time function only. So you can relate all the things from the real time applications also, and you can get your answers, means how those are going to happen. Now execute this, create the table, and then insert the values. So we have taken some values, now insert it into the employee schedule table, execute, and now check what records are provided by this. Now select star from this employee schedule. Okay, now execute this employee schedule. Okay, so we are getting as expected, and the get date is also providing you data in date time format only. So select get date, we have already discussed in date time video, that date time function video we are discussing. The get date also we have discussed, that it is providing the system date and time, current system date and time. Okay, so check this, select star from get date, sorry, plus control R, get date. Now execute this, select select get date directly, we need to mention why we are mentioning, sorry, my mistake. Now select, we can directly select the function. Okay, select get date, so as current, as current system date and time, in single column we will mention, sorry, so as current system date and time. Okay, now execute this. So what value it is providing? It is providing the current system date and time. So it is providing the date here, and this is the hour HH, this is the minute 42 minutes mm, and this is the second SS 10 second, and then 3 points for the millisecond, millisecond 1 2 3. Okay, so get date is providing us the data type date time only. Type, I think also one function is there we can use, and type also, type get date. So that is not clear to me. I need to check that thing. Type is not recognized. Okay, I will tell you means how you can check the types also. Means what data type that has. For tables, you can directly go to table definition and check. like control 3 you can mention, and see in the table definition you can find out, like this one is by built-in sp that I have mentioned in my previous video, sp underscore help. So execute sp underscore help for this table. For any table, if you want to check the definition of the table, then you need to use like this, exec execute sp underscore help. So this is a system store proc that is providing the table definition. So see, here you can get the column names and their data types. That is clear. Okay, and by default get date is providing you the data type of date time. So we are getting the date time. Now move on to the next data type what we have. Now after date time we have small date time. So small date time data type, what it is doing, the small date time data type in SQL Server is used to store both date and time values. Okay, that is fine. Similar to date time, but with less precision and a smaller storage requirement. So it is storage requirement is also less, and it is also providing less precise data. Means it will provide you data till the second only. It will not show you the milliseconds. Okay, so it is suitable for scenarios where high precision in time is not required and memory optimization is a priority. So whenever the memory optimization is your priority, then instead of taking the date time, which is which is storing 8 bytes, you can use this small int, okay, small date time. Okay, that is clear. And small date time takes 4 bytes in storage, unlike date time will take 8 bytes. So that is clear to everyone. Now let's pick up this example and we will check it's working in SSMS also. Now open a new query window. All these codes, if you will comment, will provide to you, and that is it. So what we are doing here, so here we are creating a table, project deadline, and we have provided project ID integer and deadline to be small date time. Okay, now execute this and create the table. Now again, we are inserting some records, insert into the project deadline table, the column names, then values. So see, here we have put the value till the second only, because a small date time will not provide you milliseconds. It is less precise, but it also stores less amount of data. Means 4 byte it is taking only for storage. So that is also. Now go and execute this. Select star from project deadline. Okay. Now see, the data is coming as expected. Now check for the get date. We will check. We will use the string function that we have already discussed in our string function video, the cast function, and then cast the data type of get date to small date time, and then check how it is providing the result. So select get date. First we will take this, and then in second line we will use, for comparison also it will be better thing. Now cast get date, cast get date to as cast get date as small date time, small date time. So intelligence is providing us the data types also. Now execute both of them simultaneously, then we will check. See, as as date time data type dt, date time dt, we will mention date time dt as as a small date time, small date time dt. Okay, now execute both of them simultaneously so that we will get a comparison also. So see, if we are executing get date, which is a date time data type, so it is providing us the milliseconds also, and small date time we are getting till second only. And one thing also to mark, that it will provide the second only to 00. Every time any second it will be, it will provide only 0. Okay, other than 0 it will not provide the second value. So you can consider it is providing till the minutes only. The second also it is providing 00 only. Okay, it is only for showing that second is available. Okay, so date time and small date time is clear to everyone. Now let's move on to the next data type what we have. So after a small date time, we have date data type. So date is doing nothing. Let's check what it is doing. So the date data type in SQL Server is used to store only date values. Okay, it is storing only date values without any time component. So it is not providing any time component, just the date it is providing, the date data type. It is suitable for scenarios where you need to handle dates such as birthday, holidays, or event scheduling without worrying about time. So birth date generally we will mention the date only, time of birth we are not mentioning to anyone, and holidays are mentioned in dates only. Events, an event will be also mentioned on this particular date we have the event, like that kind of thing. So date occupies 3 bytes of storage. So only 3 bytes of storage date is occupying. And here we have the example also. So let's leave the example for now. Just check from here only. We will check the get date by converting that into date and check what kind of data it is providing. So here we will discuss the example here only. So here we are creating the table employees, then employee ID, and then name, then date of birth, which is date data type. And and then we are inserting this kind of value in employee ID, name, date of birth, values like 1 to 3, names, and the date only. Okay. So this is clear. Now move on to SSMS. Now we will check here by get date how the date is going to work. Okay, cancel this. Now open a new query window. Now use select get date and then as uh, as date time, date time dt data type, and then cast it to date and then check select cast get date to date as date. Here we have missed the as, cast get date as date as date data type. Now we will execute both of them simultaneously and check how the date is working. So see, the date is only providing the date. Okay, date part only it is providing, no time is there. Okay, so I think date is also clear to everyone. Now let's move to other data type. So we have not mentioned the example in date because date is a very simple one, so you can handle from there also. Now move on to the next one. So next we have the time. So time data type, like date is providing date, time will provide time. So let's check the definition once. The time data type in SQL Server is used to store time values without any date component. Okay, so it is providing the time only without any date component. It is suitable for applications where only time portion is needed, such as tracking work hours or store opening or closing time. Okay, so punch in punch out time and store closing opening time and working hour tracking, how much hour you have worked. So in that, date is not required. You can only check the hours for that particular date. That much will be enough. So in those cases, the time data type is required. So the time data type requires 3 to 5 bytes of storage depending on the precision specified. So here precision is how much part of time you are going to get. So that storage capacity will depend on that. Like if you want more precision in the millisecond part, so the storage will be bigger, like 3 to 5 it will go, so it will be 5 around something. And if you want it smaller, then it will be less, like between 3 to 5. Okay, so now here we have the example. We will check from here. Now copy this example and we will go to SSMS and then execute this. So what we here we are doing, create work schedule table we are creating, and then the column are employee ID, start time, end time. So start time and end time are time with two precision, means millisecond we want in two till two parts. After the means millisecond we want the two parts only. Okay, execute this and then here we have some records. Insert the records. 17 seconds we are mentioning here. Okay, now execute this inserted value and check the values how it is providing. So select star from this work schedule. Now execute this. So what we are getting? Okay, so you can see the values are coming as per expectation. So what it is providing? This is the 08 is the hour HH part, this is 30 is the mm part, and this is 00 is the second part, and this particular dot 00 is the millisecond part. Okay, similarly we will check from get date also. Now go and check in get date what values it is providing. So first we will use like select get date as known, we will mention as known. Okay, no, wn known, and then select cast. You can cast any data type to any data type, but you must be aware that integer cannot be converted into varchar. The possible data type you can convert only. Integer cannot be converted into varchar, and means varchar cannot be converted into date. Like these kind of, you need to check while you are doing the cast function, na, then you can get the idea about on what data type you can convert and how you can convert. So we can convert this cast, as these all are related to date, time and time, so we can cast each of them, means one to other. Okay, so cast get date as time, and here we will take the precision up to 5 digit. Okay, now see, as timed. Okay, now both of them we will execute simultaneously. So see here what you are getting. So here you are getting the date time data type. So the millisecond is in three, is up to 3 digits only here, and here in timed, when we are taking the precision to 5 digits, what it is providing? It is providing the millisecond up to 5 digits. Here you can see HH part, MM part, SS part, and then millisecond part is up to 5 digits. Okay, so this is clear to everyone. Okay, now let's move on to the next data type what we have. So these data types you are going to use regularly on your day-to-day work while you are going to work in a organization or in a corporate. Okay, now after time what we have? After time we have the date time offset data type. Okay, so if you are going to handle the means global clients and all, then you need this particular data type very um, often. And if your data is related to means global clients from different location and all, then this particular data type you are going to use very often. So be clear on this particular data type. So date time offset, what it is doing? So the date time offset data type in SQL Server is used to store both the date and time along with the time zone offset. Okay, so it is also providing you the time zone offset along with the date and time. Okay, so this make it ideal for applications that deal with global data, or global date and time values. Okay, as it accounts for variation in the time zone. So it accounts for the variation in time zone, means it will provide the different time zones also as per the data you have. Okay, so date time offset requires 10 bytes of storage. The storage capacity of this is also very big. It is getting stored in 10 bytes of memory. So use these when needed only. It is recommended for optimization point of view. Otherwise, use the other data types with less storage. Okay. So, but when it is needed, then you need to use this if you are going to handle the global data sets. Now copy this example and we will check the working of this also. Now go, and what we are doing here, we have created a table, meeting schedule, then meeting ID we have, meeting time we have, and meeting time will be our date time offset with 3 precision. Means the millisecond is going to be shown in 3 parts. Okay, so insert into meeting schedule. Now first create the table and then insert query we are inserting some values into the meeting schedule table. Now execute this. Okay, now select from meeting schedule table. What result we are getting? We will check. Select star from meeting schedule table. Okay. Now the results are coming as it is. Okay. Now we will also check using the get date how it is working. So select get date plus control R, first click and remove the result tab. So select get date as known, and then select cast get date to get date cast it to as date time offset date time offset date time offset. Okay, as offset data offset as offset. Okay, now when we execute this, what result we are getting? So see, so it is also adding the offset here. So it is adding 00 because the server is also downloaded in my system, and the time it is capturing for my system only. So here for this particular position it is 00 itself. Okay, now you can see the difference here in date time. We are getting only 3 means only until millisecond, and here so this point also need to be noted that by default the millisecond precision will be of 7 digit in date time offset. So this is 1, 2, 3, 4, 5, 6 and 7 we are getting, and the offset also it is mentioning in the date time offset data type. But in date time we don't have any offset, and the millisecond precision is up to 3 digit only. And here from here we can set our precision also for the millisecond, like 2 also we can do. So if we do 2, then what it is providing? Check the result. Now see, here it is. After the millisecond part is up to 2 digit only. And if we increase it to 7, then 7 it is providing. And what will happen if you provide it 8? Let's check once. 8. Now, so it is throwing error. See, the IntelliSense is throwing error. The Microsoft SQL Server. 1 second. We will execute this and check the error. Plus Control R. Then execute. Specified scale. See, specified scale 8 is invalid. So specified scale is invalid. Now when we mention 7, then it is taking this. Execute this. So it is working fine. Okay. So I think date time offset is also clear to everyone. Date time offset is providing the offset also with the date time. Okay. Now move on to our next data type and the last data type of this particular session. So what is it? Now after date time offset, we have date time 2. So date time 2 data type is also one kind of data type that you are going to use very often, and what it is doing. So the date time 2 data type in SQL Server is an enhanced version of date time data type. Okay, offering more precision, a large range, and a smaller storage size. So it is providing you everything, like more precision also it is providing, and large range also it is providing, and smaller storage space also it is providing to you. So it is very useful for optimization point of view also, and if you want to store a large data, then at that point of view also it is very useful. And it is commonly used when higher precision or a wider range is required. When higher precision when you required, then you need to use date time 2 data type. So date time 2 requires 6 to 8 bytes of storage depending on the precision specified. So what precision of millisecond you are going to take, so on that only date time 2 data type storage will be depending. Okay, now here we have the example. We will copy this and use this. So the maximum precision it will provide up to 7 only, 7 for the millisecond. This will also provide that much only. Now open a new query window and then paste this. Then here what we are doing, here we have created a event log table, and then event ID and event timestamp we have. Event timestamp is the date time 2 data type with the precision of 7 milliseconds and 7 digits in millisecond part. And then execute this. The table is created. Now we are storing some values. So store this and then put a select star on it. Select star from events log. Now as you can see we are getting the data as expected. Now we will try the whole case with the get date also and compare once for the date time 2 data type also. Now select get date. So from by this you can get the difference between date time and date time 2 data type. So get date is date time known, and then select cast get date to date date time to data type, and we will take, either you can take the precision, we will take the precision up to 5, and then as 5 it is not taking, why? Incorrect syntax expecting. So cast get date as it is expecting as, okay, as this, and now it is fine. Okay, as uh, to date time, to date time. Okay, date time underscore 2 underscore 2. Remove the 2 from the beginning. Okay, now control R. Now execute both of them. So known. So you can see here the precision is little bit higher for date time 2, and the storage capacity is also between 6 to 8 bytes. One second, I will recheck and confirm. 6 to 8 bytes, as you can see here. Okay, now go here and check. Here we can also increase the precision to 7 and execute this. And what will happen if we increase the precision by 8? So see, it is the intelligence is providing us the error. The Microsoft SQL Server is not getting. Now execute this and check. Press Ctrl R, then execute this. What it is providing. So is specified scale 8 is invalid. So maximum precision we can give is up to 7 characters for millisecond. That is clear to everyone. And thank you for watching the whole video, my friends. And many more videos are on the way, and you need to cover other data types also. So two parts of the data type will also going to come, and other than that we are going to make a full playlist on SQL tutorial from beginner to means hero, zero to hero level. And if you need any help, like, share and comment, and like our channel and subscribe, increase the channel growth, then you will, it will reach to many people, and many people will get benefit from the video. And for live training and all, for online trainings, you can contact to our number. And thank you everyone. Thank you.